today is molality, which is the unit molality, otherwise known as M, is used to express the concentration of a solution. This is the equation of molality, which is moles of a solute over kilograms of a solvent.
Don't forget, 1 kilogram equals 1 liter.
Our molality problem today is how many grams of potassium iodide must be dissolved in H2O to produce a 0.06 mol/Ki solution.
This is CP1.
So to start this problem, we find our knowns. Our first known is mass of H2O is equal to 500 grams, and when you do mole problems, you convert grams to kilograms.
Where's the pen?
So we converted 500 grams to 0.5 kilograms of H2O. Our second known is the solution concentration is equal to 0.06 mol/Ki. And our third known is the molar mass of potassium iodide is equal to 166 grams per mole, which we concluded from a periodic table. And lastly, our unknown is the mass of a solute equals how many grams of Ki. So to solve this problem, we will use dimensional analysis and start with your unknown. Your unknown is grams per Ki is equal to, and then you use your first known of 0.5 kilograms of H2O then you multiply that by your first conversion factor, which is 1 kilogram H2O, and your second known, which is your solution concentration, to 0.060 moles Ki. Then you multiply that by 1 mole Ki, and your third known, which is 166 grams, of potassium iodide and 1 mole potassium iodide. And your answer will get, well, first you cross out your labels, so you have kilograms of H2O crossed out, kilograms of H2O, moles of potassium iodide, moles of potassium iodide, and you're left with grams of potassium iodide. And your answer will be 5 grams potassium iodide. And that's how you solve a molality problem.
Okay, for our second molality problem, we have how many grams of sodium fluoride are needed to prepare a 0.400 molal NaF solution that contains 750 grams of H2O. First, we start with our unknown, which is grams of NaF. This equals our known, which is given to us in 750 grams. We are then going to convert it into kilograms, making it 700.750 kilograms of H2O. Now get ready. Here comes our conversion factor. We are given 0.400 molos, which is then going to be 0.400 moles of NaF over 1 kilogram. So now we're going to put this into the equation. So it goes times 0.400 moles of NaF over 1 kilogram of H2O. So that crosses off, and that crosses off. Next, on the bottom, we're going to put moles. So we're going to put 1 mole of NaF. And on top, which we concluded from our periodic table, we're going to have 42 grams of NaF. So then moles cross out, and using a calculator, you do all the multiplications, and your answer should be 12.6 grams of NaF.